Today, let's build a prediction machine. But forget gears and wires. We're going to use pure mathematics to peek into the future. We're going to demystify one of the most fundamental tools in all of data science and AI, linear regression.
So let's start with a simple question you've probably asked yourself. We all kind of know that studying more should lead to a better grade. But what if we could predict the exact score you'll get? What if we could build a little machine to do just that? And believe me, this isn't just for grades. The same logic is used to predict house prices or to forecast a company's sales next quarter.
You know, our intuition, that gut feeling, tells us there's a connection here. But machine learning, that's what takes our hunch and turns it into a cold, hard formula. It's not about what should happen, it's about finding the actual pattern in the data to prove how it happens.
Now, this is probably the most important thing to get. People love to talk about AI like it's this mysterious, unknowable black box. But it's not. Today, we're going to pry that box open and look at the engine inside. And you'll see, pretty quick, it's not magic. It's just math.
So, how do we start? Well, every machine needs a blueprint. And for our little prediction machine, that blueprint is something we call the best fit line.
I want you to picture a chart. On it, there's a whole cloud of little dots. Every single dot is a student, placed based on how long they studied and the grade they got. Our entire goal here is to draw one single straight line that slices right through the middle of that cloud of dots as perfectly as it possibly can. That line, that's it. That is our prediction machine.
And here's what that blueprint looks like in math terms. Our entire job, the whole thing, boils down to finding the two missing numbers here. The coefficient, that's just a fancy word for the power of each study hour, how much each hour is worth. And the base grade, well, that's the score you're starting with before you even begin. Once we find those two numbers, we're in business.
All right, blueprint's ready. Time to get our hands dirty and actually assemble this thing. And it all comes down to calculating those two key numbers using our data. Every project needs raw materials. For us, it's data. A simple list, right? On one side, how many hours a student studied. On the other, the grade they got. This right here is the fuel for our machine. Now, the actual formula behind this can look a little intimidating, but really, you can break it down into four simple, logical ideas. First, you find the center of your data, the averages. Then, you see how spread out everything is. You use that to figure out the relationship. And finally, you set your starting point. That's it. So, after we run our data through all those steps, the math spits out the two magic numbers we've been looking for. This is the heart of our prediction machine right here. Our first number, the coefficient, comes out to be 4.76. This little number holds the entire key to the relationship we're looking for.
And our second number, the base grade, is 5495. This is our starting block. So now, we just plug those two numbers back into our blueprint, and just like that, we have a working prediction machine. We've successfully found the simple, elegant pattern that was hiding in our data all along.
Okay, we have the equation. We built the machine. Awesome. But what do these numbers actually mean? Because that's where the real power is, understanding what this thing is telling us about the world.
So that first number, 4.76, that's the engine of our model. It's telling us the precise value of 1 hour of studying. According to our data, for every single additional hour a student hits the books, their grade is predicted to climb by 4.76 points. That's the payoff.
And the second number, 5495, that's our baseline. It's what the model thinks a student might get even if they studied for, well, 0 hours. You can think of it as the starting score that all your hard work builds on top of.
So we've built the machine, and we know what it all means. But you might be wondering, in a world with incredibly complex AI, why does this simple little straight line matter so much?
Well, the power is in its clarity. With a linear model, we can explain exactly how it got its answer. We know why it made its prediction. But with some of those huge, more complex models, yeah, they might be more powerful, but trying to figure out the why behind their answers can be nearly impossible. They can be a true black box. This relationship is fixed, it's predictable, and that's what makes these models so transparent and so trusted. It's not a mystery. An extra hour of studying always adds 4.76 points to the score. It doesn't matter if it's your first hour or your 10th. That simplicity is its greatest strength. So just think about it. We've just used a simple, straight line to connect study hours and exam scores. This exact concept is powering everything from financial models to medical research. It really makes you wonder, doesn't it?
What other hidden patterns could be hiding in the world all around us, just waiting to be understood?